Okay. So let's have a look at this one. Let R be the region in the first quadrant enclosed by the graphs of 2x, which is the line, and x squared, which is the parabola. Shown in the figure above, find the area of R. So if we set that up, we would go from 0 to 2. And we would do top curve minus bottom curve. So if I integrate that, I get 2x squared over 2, or just x squared, minus x cubed over 3 from 0 to 2. So 4 minus 8/3, and we don't have to, again, worry about the 0. So that would be 12/3 minus 8/3, so 4/3. Is that what you got? So let's see, the 2009, number 4. Maybe I'll find it. There we go. Yeah, that one's worth 3 points, so that's nice. A point for the integrand, that's this part here. A point for the antiderivative, and a point for the answer. Three points on a free response is pretty good. Like, I mean, that's a good amount of points to get. So you're already there without even doing the other 2 parts. Okay, so in part B, the region R is the base of a solid. For this solid at each x, the cross-section perpendicular to the x-axis has this area. Find the volume of the solid. Okay, so what we said before was that when we're doing volume of a solid, we integrate the area of its cross-sections. So when we do discs, we're doing circles, or washers, we're doing circles with holes cut out. We did one with a rectangle. Well, in this case, they don't tell you what shape it is, but they tell you what the area is, and that's all you really need. You just have to integrate area to get volume. So at each x, so we're going perpendicular to the x-axis, so we're going this way. So we're going to integrate from 0 to 2 this area formula. So the sine of pi over 2 x dx. So the setup is not hard on this one. You just integrate area. What's hard is actually integrating it, because they don't just tell you to set it up. They tell you to integrate it, and so you got trig. And you also have u substitution. So in order for me to integrate this, I have to use u substitution because I have one function inside of another one. And what's on the inside we would call u. So what's the derivative of that? The derivative of pi over 2 times x. Just pi over 2, right? And we have to have that as part of our integrand right here. So we don't have pi over 2 on the outside, so we have to give ourselves a pi over 2, which we would balance with a 2 over pi. So now we can integrate it. So I'm going to come down here so I have more room. So I'm going to have 2 over pi. When I integrate, the pi over 2 and the dx go away because they're both part of the derivatives of the inside. Pi over 2 dx is the derivative of the inside that goes away when we integrate. So we get, if we integrate sine, we get negative cosine. I'm just going to put the negative out here so I don't have to mess with it being in there. Negative cosine, and then we keep our u from 0 to 2. Alright, so I'm going to have negative 2 over pi times the cosine of pi over 2 times 2, so that would be cosine pi, right, if you plug 2 in. The cosine of pi minus, and then if I plug 0 in, I get the cosine of 0. Yeah, I just put the negative 2 over pi out here, so I would multiply both of them by that.
But where'd you get the negative for?
Oh, because when you integrate sine, you get negative cosine.
Oh.
So I just put the negative out there so I wouldn't have to keep it with the cosine.
Oh.
Does that make sense?
Yeah.
Okay, so the cosine of pi and the cosine of 0. So 0 and pi are both on the x-axis. 0's over here, pi's over here. This would be at 1, 0, and this would be at negative 1, 0. And cosine's the first number. So the cosine of pi is negative 1. The cosine of 0 is 1. So we have negative 2 over pi times negative 2. So that would be positive 4 over pi. So let's see if that's right. I always get nervous. You would think this is not the first time I've worked this problem. You think I wouldn't get nervous anymore. But I do. Alright, so that one was worth 3 points as well. If you just recognized that to get volume you need to integrate area, you would get a point. So even if you couldn't do the trig stuff, integrating sine or plugging in, you could still get one of the points. So just setting it up as a point, then integrating it and knowing, that you had to use u substitution, so you'd get this 2 over pi, and when you integrate sine, it's negative cosine, that's another point, and then a point for plugging in and getting the answer. So you should always try a problem, even if you can't finish it, it's partial points. So if what you've done up to that point is right, then you're good. Okay. Part C, another solid has the same base r. For this solid, the cross section is perpendicular to the y-axis. So now they're going this way. So perpendicular to the y-axis are squares. Write but do not evaluate an integral expression for the volume of the solid. So we have to integrate the area of each of those squares. So we know that the area of a square is just side squared. So if we could just figure out how long one of those sides are, we just have to square it and integrate that. So we're going to be integrating from 0 to 4 because we're going perpendicular to the y. So 0 to 4. And then one of those squares, the side length is just the distance between these two curves this way. So I know that from the y-axis to this curve, it's the square root of x. Right, because this is y equals x squared. So if you solve that for x, you get the square root of y. I mean the square root of x. No, sorry, the square root of y. Yeah, the square root of y. So this is the square root of y this way. And then this, from the y-axis to this curve, would be y over 2. If you solve your other equation for x, you get y over 2. So the difference between those is the base of one of those squares. So we would do the square root of y minus y over 2 squared. And that's all you have to do on that one, is just set it up. So that was worth the last 3 points. 2 points for this part, and 2 points for the limits, 0 to 4. I mean 1 point for the limits. Does that make sense? A little bit? Alright, let's see. What if we look at let's look at the 2011 test, number 3. We'll do one more of these, and then there's a couple of other ones in here that you can look at on your own, but we'll do one more of this type. So look at 2011. This is number 3. This was, I think, the first year that they went to 2 calculator free response and 4 non. So number 3 used to would have been on the calculator section, but this year it wasn't. So it's kind of similar to the one we just did. You're going to have some trig. This is 2011. Number 3. We're kind of skipping around. Alright, So take a few minutes to try that one.